Hello students, this is a continuation of the last two videos. Now we'll start with the problems on the Cartesian form of the curves. The first example will be Folium of Descartes given by the Cartesian equation x cube plus y cube is equal to 3axy where a is a constant greater than 0. Solution. First, we'll see the symmetry. Symmetry. The curve is symmetric about the line y is equal to x because when you replace x by y by x for example, then the equation remains the same. Therefore, the curve is symmetric about the line y is equal to x. The second point is the origin O00 is a point on the curve. That is, when x is equal to 0, then y is equal to 0. Therefore, the curve passes through the origin. Now we find the tangent at the origin. The tangent at the origin are obtained by equating to 0 the lowest degree term, that is x cube plus y cube is equal to 3axy. In this, the lowest degree term is 3axy is equal to 0. As a is not equal to 0, the product xy must be equal to 0. Therefore, x is equal to 0 or y is equal to 0. Hence, x is equal to 0, y is equal to 0. The y-axis and y is equal to 0, the x-axis are tangent at the origin. These are coincident tangents. Third, the intercepts. There are no x-intercept and y-intercept except the origin O00 because by putting x is equal to 0 in the given equation, we get y is equal to 0. Similarly, by putting y is equal to 0, we get x is equal to 0. Then the intersection of the curve with the line y is equal to x. Put y is equal to x in the given equation. Then we get x cube plus x cube is equal to 3ax into x. That is 2x cube minus 3ax square is equal to 0. Implying thereby x square into bracket 2x minus 3a is equal to 0. Implying thereby x is equal to 0 or 2x minus 3a is equal to 0. Then 2x is equal to 3a or x is equal to 3a by 2 is also equal to y. Thus, the line y is equal to x meets the curve in the 2 points, that is the origin 0, 0 and 3a by 2, 3a by 2. Then we'll see the next point, region or extent where the curve exists and where the curve does not exist. For example, when both x and y are negative simultaneously, equation of the curve is not satisfied. That is minus x cube plus minus y cube is equal to 3a minus x into minus y. That is minus is taken outside, becomes x cube plus y cube is equal to 3axy. Then the left hand side is a negative quantity, whereas the right hand side is a positive quantity. Therefore, thus the no part of the curve exists in the third quadrant, that is minus x and minus y. Then the next point we'll see the asymptotes. Since the coefficient of the highest power of x and y are constants, there are no asymptotes parallel to the coordinate axis. The oblique asymptote is obtained by substituting y is equal to mx plus c in the given equation and solving it. We get m is equal to minus 1, c is equal to minus a. Therefore, there is an oblique asymptote given by y plus x plus a is equal to 0. With above points, the approximate shape of the curve is given by this. Here 0, 0 is the origin, y is equal to x is the line, the curve is symmetric about this, and the curve meets at the point 0, 0 and 3a by 2, 3a by 2. Then x plus y plus a is equal to 0 is the asymptote. Therefore, this becomes the curve x cube plus y cube is equal to 3axy. Then we'll take the second example, for example, that is the cissoid y square into bracket a minus x is equal to x cube where a is greater than 0. Solution: the given curve is symmetric about x-axis since y square is present in the equation and y is replaced by minus y, the equation remains the same. Therefore, the curve is symmetric about x-axis. By substituting x is equal to 0, we see that y is also equal to 0. Therefore, O 0, 0 lies on the curve. The tangents at the origin equating to 0, the lowest degree term, that is y square is equal to 0. Thus, x-axis is the coincident tangent to the curve at the origin. Hence, origin is a cusp because here the two tangents are equal and they are equal to 0. Then the next point, intercepts, only intercept point is x is equal to 0, y is equal to 0. That is, the origin is the only point where the curve meets the coordinate axis. Then the asymptote. Asymptotes parallel to y-axis are obtained by equating to 0 the coefficient of the highest degree term in y, that is a minus x is equal to 0. Thus, x is equal to a is the asymptote for a greater than 0. The asymptote x is equal to a is parallel to y-axis and lies to the right, y greater than 0. Since coefficient of x cube is constant, no asymptote parallel to x-axis. The above approximate shape of the curve by using the above points is given by, now we have at this origin there is a cusp and this is a double tangent, that is the x-axis, and it meets the curve at a0 and 0, 0, and x is equal to a is the asymptote. We'll take the third example, which is lemniscate of Bernoulli. Y square into bracket a square plus x square is equal to x square into bracket a square minus x square, or x square into bracket x square plus y square is equal to a square into bracket x square minus y square. Solution: curve is symmetric about both the axis, x-axis as well as y-axis, because you are having even powers of y and even powers of x. That is, it contains even powers of x and y. Therefore, the curve is symmetric about both the axes. Then second point, O 0, 0. Origin lies on the curve when x is equal to 0, y is equal to 0. Then the third point, tangent at the origin are obtained by equating the lowest degree term, that is y square minus x square into bracket a square is equal to 0. Thus, y is equal to plus or minus x are the two tangent to the curve at the origin. Hence, the origin is a node. Here you are having two distinct tangents at the origin. Therefore, the origin is a node. Then the fourth point is asymptotes. No asymptotes parallel to x-axis because the coefficient of x raised to 4 is constant. No asymptote parallel to y-axis because the coefficient of y square has no real factors. Then the intercepts. Intercept, x-intercept is 0, 0. Y-intercept is x square into bracket a square minus x square is equal to 0, or x is equal to 0, or x is equal to plus or minus a. Thus, the curve meets the x-axis at the point a minus a0 and b a0. The shape of the curve by using the above points is, this is the origin. The origin is a point on the curve. The curve is symmetric about x-axis as well as about y-axis. Then these are the tangents at the origin. Y is equal to x and y is equal to minus x. And these are the points x is equal to a and x is equal to minus a. This is the curve for the above equation. Then we'll see the fourth example where we're having what we call this as a trapezoid. given by y square into bracket a plus x is equal to x square into bracket b minus x. The curve is symmetric about x-axis. Y is replaced by minus y. The equation remains unchanged. Hence, there is a symmetric about x-axis because you are having y square is a even power term. It passes through the origin when x is 0, y is equal to 0. Therefore, O00 is a point on the curve. Then to find the tangents at the origin, what we do is we solve this equation. It becomes y is equal to plus or minus root of b by a into x are obtained by equating to 0 the lowest degree term. Which is the lowest degree term? This becomes y square into a, x square into b. Take on this side becomes bx square minus ay square to 0. Then we get y is equal to plus or minus b by a. Origin is a node since these are two distinct and real tangents. One is a plus value, another is a minus value. Therefore, this becomes a node at the origin. Then intercepts. X intercept, put y is equal to 0. You get x square into bracket b minus x is equal to 0, implying thereby x is equal to 0 or x is equal to b. The curve meets x-axis at the origin 0, 0 and a b0. Y-intercept, put x is equal to 0, then y is equal to 0. So origin 0, 0 is the only y-intercept. Then asymptotes. No horizontal asymptotes since coefficient of x cube is constant. X is equal to minus a is the vertical asymptote obtained by equating to 0 the coefficient of y square, namely a plus x, that is a plus x is equal to 0 implies x is equal to minus a. Then we'll see the loop. Since curve crosses x-axis, that is x intercepts at the point the origin 0, 0 and a b0 and is symmetric about x-axis, there exists a loop between O and A. Then we'll see the region where the curve exists or the curve does not exist. Solving for y, we get y is equal to plus or minus x b minus x upon a plus x to the power 1 by 2. Y becomes imaginary when x is greater than b and when x is less than minus a. Thus, the curve does not exist below these points and x is equal to minus a and x is equal to b, that is for minus a less than x less than b. The approximate trace of the curve by considering all above points is this, that is it passes through the origin, then this becomes the node and this becomes the point a b0, x is equal to b, x is equal to minus a. Then in particular, in the above equation, we can get two more problems. The two more problems are just putting a is equal to b in the above equation of the curve. Then the equation of the curve becomes y square into bracket a plus x is equal to x square into bracket a minus x. That is b is replaced by a. And the trace of the curve is the same as above, just replace b by a. That means this becomes, instead of x is equal to b, write x is equal to a. That becomes a becomes a point a0. So here you are having x is equal to minus a as it is. So therefore, this is a fifth problem where b is replaced by a. Then the sixth problem will be when b is replaced by a and x is replaced by minus x, the equation of the curve is y square into bracket a minus x is equal to x square into bracket a plus x. Then the trace of the curve exactly above opposite to the next part. This becomes in the form of this is the origin. Then here you get a point that is b minus a0, x is equal to minus a and x is equal to a, because you are getting a is equal to b becomes x is equal to a. Now this becomes the trace of the curve. Now these are the problems that you have to remember for solving the Cartesian curves. The points you are having, the 6 points nearly, that is that points will get 3 marks in the examination and the shape of the curve will get 3 marks in the examination. That becomes a 6 marks question on the Cartesian curves. Then in the next video, we'll see that the main points for tracing the curve in the polar form and the corresponding polar curves. For today, thank you.